So this is a molecule which is given, and if you look at this molecule, water and 80 degrees, so anything above 50 degrees will be elimination reaction. So if you look at this loss of this chlorine, when the chlorine is removed, we get a cation, carbocation. Now if we look at alpha H in this case, so there will be 2 to 4 and 5 alpha H will be present. So there will be shift, so there will be a hydride shift in this case. So any hydrogen here, it will shift here, so there will be hydride shift. Now if we look at alpha H will be 3 plus 3 6, and in this case it will be 7. So any arrangement, any alpha H, if it is increasing, only then that carbocation will be stable. So in that case alpha H has increased from 5 here, where there is a hydride shift, and by hydride, this is a hydride shift, and by this hydride shift, what has happened is the carbocation, that is the positive charge, has shifted here, and now there is elimination. Elimination can be, a hydrogen can be lost from here, or a hydrogen can be lost any of these regions. So the major product in this case will be this, because more substituents. This is Sedzeff product, we can say, and this is Hoffman product. So there is loss of this hydrogen, which will result in a double bond here. So this is a major product and this is a minor product. If you look at the second reaction, again there will be loss of this chloride ion, which results in 300 degrees. So whenever 300 greater than 50 degrees, it is even reaction. So in this case there is a carbocation here and a carbocation, and this is already resonance stabilized, and because it is resonance stabilized now, hydride or hydrogen will be lost from this carbon, resulting in double bond. An interesting example and most important example is given here. Please observe this carefully, make a note of this now. So this is a compound which is given, this is chlorine. When chloride ion is lost in this case, that is, if Cl is lost here, there is a positive charge which is formed. Now if there is a ring here in this case, and there is a positive charge immediately outside the ring. Now this is a classic case of ring expansion. Now ring expansion from 4 to 5 ring carbon structure here, and if you look at this, if you number this as 1 2 3 4 5, so this bond, the bond between 1 and 2 will be broken, and a bond between 3 and 1 is formed. So this is an intermediate structure. Please practice this, you'll understand that. So I have directly drawn 1 2 3 4 5 carbon structure here is formed. So 1 2 3 3 1 2 3 4 5, the carbocation has shifted to the second carbon, as you can see. Now there is something called as, if this is a carbocation, the number of hydrogens will be alpha H in this case. If you look at the number of alpha H in this case, the number of alpha H will be 2. Now because of the methyl shift, now if methyl is shifted here, the number of alpha H will increase to 5 in this case, as you can see here. Now when it increases to 5, now either this hydrogen or this hydrogen will be eliminated. We will get either this as a product or this as a product. So this will be a major product, quite an important problem. This, I mark this as most important problem, which can be asked in JEE mains, or it can be asked in the NEET examination. Please practice this, please follow this meticulously, so that you'll get a good understanding of the concepts of uh, elimination, that is the condition, the concept of ring expansion, the concept of methyl shift. All these concepts are uh, very much present in this problem.